Hi everyone, welcome to Codebuff Day 3 of Launch Week. I'm James,
I'm Brandon.
and we're the co-founders of Codebuff. So I'm really excited. This week we announced that we went fully open source. We also beat Cloud Code in evals, and we are launching a SDK for our new agent framework. So I'm really excited, and I hear that our users had some questions about that.
Yeah, that's right. Over the last couple of days, your response to our launch has been amazing, and we've just compiled down some of the most common questions, and I'll just go ahead and ask them to you. All right, they're going to be a little bit hard hitting, so
Oh boy.
hopefully you're prepared. Okay, so first things first, we went open source,
Mhm.
right? Why now? Why not before?
Yeah, it's a great question. I kind of almost wish we did it earlier, actually. I think that looking back, I think it would have only have benefited us. I think people are a little bit too they're too resistant to go open source. But there actually were some real reasons where we're like, oh, now is a really good time to go open source. So if you were following along, we announced this whole multi-agent framework. And I think that when we thought about the vision for what that was and what it could become,
Mm-hmm.
it just like combines with open source so well because basically we want people to be able to publish all these agents, and we want them to rely on the framework. And I think if they can see the underlying source for that, if they can like contribute to fixing bugs or even like fork it and run it
Mm-hmm.
themselves, that gives them a lot of security and stuff. So I think open source was just like it just became too many reasons like why that we should basically it was over determined that we should become open source.
Yeah, and I think maybe a big part of it also is like the fact that we want people to be building on our framework, our SDK, and to do that, you want to have assurance that even if something happens to us as a company, people can still use this and be totally like fine being able to build on it, right?
Absolutely, yeah. The long-term prospects for the framework. Yeah.
Mm-hmm. Cool. And so, as part of our announcements, we talked about an eval
Hmm.
that we've done, and that's better than Cloud Code.
Hmm.
So,
Buff
one
bench.
yes, spot bench. What I'm wondering is, I guess people online are wondering like, why not Sweet Bench? Like, why not Terminal Bench? Like, there's so many out there. Why do we have yet another one?
Yeah, this is a really good question. And basically, we had to try them and see for ourselves what we thought. There's like we have a long history over a year. We've tried different evals, and
We actually never wanted to make our own. Like, we
yeah,
would
no,
want
we
to just
didn't.
pull
Yeah,
something
we
off
were
the
like,
shelf.
of course, we'll just get use Sweet Bench. Like that makes sense. But actually, we kind of found that it doesn't make that much sense because really eval should be like very specific to your product. And I think for Sweet Bench, it's sort of like a little bit different. Like the task that you have doing, it's running autonomously for like a long time.
Mm-hmm.
Whereas we have more of like there's a human that's prompting, um, and I think that the like Sweetbench in particular is like really heavy. It's like it costs thousands of dollars to run evals for it, and they actually aren't very good because what everyone is doing now to get score high on Sweetbench is literally just run like lots and like tens of copies of their like of agents to like try to maximize and get the best score. So I think the criticisms of Sweetbench there's a few of them. It's like one, it's like way too heavy. People are already gaming it by applying too much compute. It doesn't really match the form factor of Codebuff, which is like a back and forth chat, not a single response. And then one more criticism of Sweetbench is that it only detects pass fail, like did you pass all the tests, and it doesn't detect code quality.
Mm-hmm.
And that's something we also care about a lot at Codebuff. And so when we created our own eval, we actually did this months ago,
Mm-hmm.
and it was sort of like it wasn't even we had no idea what our future plans were where we didn't think we were going to open source. It was totally an internal benchmark,
Mm-hmm.
and we were just building what made sense to us to so that we could improve our product for everyone else. We didn't even need to tell anyone about the benchmark, but I think we as we kept using it, we just were like, this is really useful to us, and that was one reason why we wanted to open source
Mm-hmm.
with that.
Yeah. And so then I guess relatedly, like how do people know that we didn't just make up like a random eval, just
Yeah.
kind of like gaming it, right? Like you said earlier,
Hmm.
right?
Yeah, totally. I think you can, because we're open source, you can go back in our Git commit history and you can see for yourself that we've been working on it since I think maybe June, early June, or maybe end of May. And yeah, it was just sort of like sort of we were trying to make the correct eval for our product, and
Mhm.
for context, it actually is it uses a like we have a whole an agent that pretends to prompt the like prompt our coding agent over a series of turns. So
Mhm.
it's like
Acting like a human.
it's acting like it's
Mhm.
pretending to be a human pretty much, and like sending the prompts. And then at the end we have a judge that compares what the Codebuff output versus like a real git commit that we were basically re-implementing, so it could sort of judge how well you did. And it turns up so many issues where we're like possibly like duplicating code or whatever. And by the way, Cloud Code also has all these problems.
Yeah. I think it's worth noting that like we didn't really even know how Claude Code would perform until like last week, right
Yeah,
before
that's right.
we
Actually,
did
we
this.
had never run it with Cloud Code,
Yeah.
and we were just like, "Whoa, we should probably do that at some point," but we never got around to it.
Hmm.
And then when we finally did run it, we were actually surprised to see that we were like firmly ahead. And
Hmm.
I know some people are very skeptical, and they're like, "Oh, so you just like rigged your own eval to show that you're ahead?" Well, actually, we fine tuned our eval like just to be good for our product, and then we like 1 week ago basically we're like, let's try running Cloud Code, and then we were ahead. So
Hmm.
that was a nice surprise.
Yeah, and I think worth noting that like you know had we found that like Cloud Code had done better, we would have like gone back. We could have gone back and like
Hmm.
modified like the benchmark. Like we could have done a lot of things to do that, and we didn't. Like we
Yeah,
just were like, oh, it's surprising that that was better. Maybe we could build a headline around this. That was kind of the thought,
yeah,
right? Cool. Okay, so um, moving beyond that, I guess, like, I think one of the things that we've heard from people recently has just been that Codebuff seems a lot more expensive on a per kind of like token basis, right? Um, I don't know. What do you think about that?
yeah. I think it's a good like maybe criticism of Codebuff. I think we've always been trying to get the best quality.
Mm-hmm.
So one of the ways we do that is we'll just read like whole files, and we'll read a lot of them.
Mm-hmm.
I think we never wanted to be stingy in terms of like getting the best results. And I think that this is one of the reasons why we do better in the evals compared to Cloud Code is
Mm-hmm.
actually because of this philosophy. So that could be a contributing factor. I think there's actually a lot of potential for us to sort of have the best of like all worlds maybe, because with our framework we're allowing people to compose these agents. We ourselves
Mm-hmm.
have even made like a light mode, which is like a cheaper version of Codebuff, and that's definitely way cheaper than Cloud Code. You should try that out. But our kind of vision is to just fill all of the trade-offs. So like
Mm-hmm.
I think there's three main dimensions for trade-offs, where it's like it's the cost, it's like the quality,
Mm-hmm.
but it's also the speed. And so I think that some people just prefer things faster, some don't care about speed, and some people like care about money or not, and quality, of course.
Mm-hmm.
So I think that basically we should be able to build all the combinations for all of those that get the
Mm-hmm.
Pareto frontier
Mm-hmm.
for all of them.
And that's kind of the goal, right? It's not so much that base code buff, as great as it is like going to be the best fit for everybody. Like we just don't know who's got what needs, who cares about what. But it's like that it starts as a good basis for you to
Yeah,
like,
we had to choose one place for everyone to enter, and maybe that's a little bit too expensive for
mm-hmm.
some people.
Yeah. But then, there's every hope, I think, from our end that people will, take inspiration, right? We're fully open source. Everything is visible. You can just take ideas that you like and create your own agent. And hopefully that works better for you for all these other dimensions that you care about.
Totally.
Yeah.
Yeah.
Okay, cool. So I guess speaking of framework, I want to ask you about a big question that we've heard a lot from for hesitations from people, which is how do you know that this is the right abstraction, right? Others in the past, other frameworks in the past have kind of like had too many rigid designs that couldn't evolve as the LLMs continue to change and improve, right? Tool calls, for example, were just not really like a thing, even a year ago, and now they've become kind of a core aspect of all these agents. So, how will we evolve over time, and how have we thought about this?
Yeah, I think it's a great question. I think while they maybe did have some form of tool calls a year ago, the like LMs have changed incredibly. The models have been trained, in fact, to be like basically agents. So like instead of doing one-off LM calls, which maybe calls a tool or two, it's designed to sort of go back and forth, where it uses a series of tools, and it like takes in information, which it uses to call more tools, and then finally can like take actions. And so
And that's basically an agent, right?
that's an
That
agent.
is.
Yeah,
Mm-hmm.
basically, like this is the year of agents,
Mm-hmm.
as OpenAI said, but it's really true that all of the models just have completely transformed. If you compare like GPT 4.0, which like barely knows how to call tools,
Hmm.
to GPT 5, it's like night and day. They just like work differently, and I think that because they work totally differently, that actually means you need a totally different framework. And I think that most of the popular frameworks today, like Mastra and etc., they were sort of built at an earlier time before agents really became popular or like available at all. And so this is one reason why it's like one reason why we decided to go all in on building a new framework is because we thought that there was just missing capabilities. And the other thing is that we just sort of like built it for ourselves and found that it worked. And so it was sort of like it's not necessarily we started out to like build an agent framework, like who needs another one of those,
Hmm.
right? But like it was more that we just internally reorganized our code base and was like, wow, this is magical. This abstraction seems
Hmm.
so good. And
Hmm.
then we just wanted to share it with the rest of you. It was sort of that it like we were pulled in that direction just because of how reality came out. But
Hmm.
yeah,
Yeah.
yeah.
Cool. Okay. All right. So in conclusion, like what makes this framework better than others?
Yeah, I think it's a really great question. I think there's a lot of factors actually beyond even the composable agents of
Hmm.
why this is a better framework. Um, I think one thing we try to do is just make it so simple to get like very powerful behavior,
Hmm.
so that the average person can just sort of define just a few fields. And one example of how we do this is we have an instructions prompt, which basically you can just dump in a series of steps for the agent to take,
Hmm.
and we do behind the scenes sort of inject that as a user role message that basically keeps the agent on task. And I
Hmm.
think if without this ability, if you just put it in the system prompt, the agent would be much harder for it to follow all those instructions, and you get much worse results.
Hmm.
So we're doing like little things like that that just sort of improve the capability for you. But another really exciting feature we have is like this ability to blend when you define an agent. It's just one TypeScript file,
Hmm.
so normally you just have like prompts and like a little bit of schema, like which model, which tools. But we also have this way where you can write programmatic code. You can write a function. It's actually a generator function, but essentially it allows you to for sure like run these tool calls first. Like make sure you like run a git diff or like read these files first, and then you can sort of alternate or like sprinkle in generation of the LM, where basically you
Hmm.
can say after you run this tool call, then run one step with the LM where it generates its response, and then maybe you look at the result and you like do some conditional logic, and then you can like run more tool calls, or you can hand it back to the LM. So basically, it sounds a little complicated, but it's just a way to blend like programmatic code with the LLM generation, and this is totally unique as far as I know for any framework, and it makes it just like way simpler. I think to do something like this in like another framework, you'd have to implement all these hard coded steps that are very rigid, and you have to like connect them, and then you have to like also put in logic about how to go between all these steps, and it would just take like 10 times as much code. So
Hmm. Yeah,
yeah.
I think one of the best ways to put it is like this function basically it's called handle steps, and it just lets you write regular JavaScript code, right? And you can just kind of call you know yields or callbacks or what have you to get the right like to hand off control as you need to.
Hmm.
Yeah.
Yeah,
Cool. Okay.
absolutely.
So then, just how would someone get started with building on Codebuff?
Yeah. So this week we're also announcing the SDK. So there's actually a couple ways to get started, but I would first just check out our GitHub repo. We have a README which explains all the ways to use Codebuff. Um, you can create your own agents, and
Hmm.
there's like a command you can run to init agents, where you can get some information about like it'll basically give you some example agents. It's super easy to like tweak them, and then you can run them with our CLI,
Hmm.
or you can install our SDK, TypeScript SDK, and start running agents in production.
Hmm. Yeah, and we'll have a lot more to share about the SDK soon.
That's true.
So
Yeah.
cool. All
Yeah.
right. Yeah, I think that's pretty much it.
Awesome. Yeah.
Yeah.
Yeah. This is great. Yeah. Keep watching for tomorrow and the last day as well of Codebuff launch week. Yeah. It's been awesome.
Cool.
Yeah.
That's it. Thanks. Bye.
Bye.